Hello everyone. So now we will see the Bode plot of first order RC circuit. So first we have shown how to write the transfer function and how to find the poles and zeros. Okay. Now we will draw the Bode plots. So first I will just show the basics of Bode plots. If you know this concept, you can skip this part. Just the basics. Okay. If you have already studied, then it will be a revision. So like this is your transfer function h of s v naught s by v in s. It is equals to s plus a upon s plus b, let us assume. Okay, and it is given that your a is greater than b. Okay, so this has some dc gain h of 0, it will be a by b, and at h equals to infinity it will be 1, right? H of 0, s equals to 0, a by b, and h of infinity means this will be a very large value, so it will be 1. Okay, now what we do in Bode plot is that we plot the we plot gain means h of s, gain in dB versus frequency graph. Okay, this is log scale. See, this is on log scale. Okay, and this is gain in dB, gain in dB means your h of omega is in dB. Okay, that you plot here. So initially what is your gain? Initially what is your gain? It is 20 log tan a by b. Let us assume it is some value this. Okay, this is 20 log tan a by b. Okay, then your a is greater than b. So first there is a pole occurring. Okay, your pole is occurring. Okay, so at b you will have a slope of minus 20 dB per decade. Okay, at b you will have a slope of minus 20 dB per decade. So one pole will give you minus 20 dB per decade slope, and one zero will give you plus 20 dB per decade slope, and DC gain will have no slope. And now what happens is that, yeah, there is some error. This should not go like this. Now you know one thing is that at h equals to infinity you have gain 1, means your gain will be, this is 0 dB. So now this will go down. Yeah, this will go down, but just as you are having a gain equals to 0 dB, at this point you will have a 0, because eventually you need to have a gain of 0 dB. Okay, and this is pole. Now this is minus 20 dB per decade. Now since we are having a 0, so the slope will be minus 20 plus 20, so slope will be 0 dB per decade. So eventually you will have a gain of 1 dB. You will have a gain, this is slope 0 dB per decade, right? A 0 is providing you plus 20 dB per decade. So minus 20 plus 20, 0 dB per decade slope. And your gain is, and this gain is also 0 dB, right? 0 dB or 1 in decimal, right? So you first will see what is the value at h equals to 0 and what is the value at what is the value of h at s equals to 0 and what is the value at s equals to infinity. So you will see the gain at 0 frequency and infinity frequency. Then by poles and zeros you will plot Bode plot. Okay, so I hope you have understood the concept, and I guess previously you also knew the concept. Okay, so now let us move on to the circuits. So this is the first circuit we are having. So again all these two concepts. H of 0 is 0 dB, right? H of 0 0 you will put, so h of 0 will be 1, so it will be 0 dB, and h of infinity will be, numerical value is 0, so it will be minus infinity dB, right? H of infinity, so here you put infinity, so h of infinity will be 0, and in numerical value it will be minus infinity. Okay, so now drawing the Bode plot, and here you only have a you have a pole, at minus 1 by RC. How to write this one? That we have already seen, right? So you only have a pole. So first you have a gain of 0 dB, 0 dB. First you have a gain of 0 dB. Then at 1 by RC, at 1 by RC, you will have a slope of minus 20 dB per decade, and it will go on. And it will go on to minus infinity. Okay. So this is minus 20 dB per decade, and this will go on to minus infinity. It will go down, 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 down to minus infinity eventually. So this is also satisfied here. So you need to make sure that this condition is satisfied. Okay. So accordingly, you should draw the Bode plot. Now in this one, you have a 0 at 0, 0 at 0, and a pole at 1 by RC, minus 1 by RC. Okay. Now drawing the Bode plot. Okay. So this h of omega in dB, and this is frequency. And what is the value at h of 0? It is 0. It means minus infinity dB. And what is the value at h equals to infinity? It is 1. It means 0 dB, right? So drawing the Bode plot, at h equals to 0 only, at omega equals to 0 only, you have a gain of minus infinity, and also you have a 0. So you will have a slope of plus 20, but it will start from minus infinity. It is starting from minus infinity. It has started from minus infinity. At omega equals to 0, you have minus infinity again. So it is starting from minus infinity. Minus infinity, it will go and go on, and at 1 by RC, at this value, 1 by RC only, you will have a slope of, this is your plus 20 dB per decade, and then you will have a slope of minus 20 dB per decade, right? So it will go on like this. So this is 0 dB per decade slope now, because you have a pole. So plus 20 minus 20 is 0, and the gain is 0 dB. Okay, so this is 0 dB gain. This increases and then goes like this. Okay, initially you have minus infinity gain, then it increases. Why did I stop it here only? Why didn't I stop it here? I didn't stop it here because I knew that at h equals to infinity, I need to make 0 dB gain. As h equals to infinity, I need to make 0 dB gain. If I had stopped it here, then simply a DC would come, right? Because plus 20 minus 20 would come. So it won't give me 0 dB gain. Okay, I need 0 dB gain. So if I had stopped it here, then I had some gain like 2 dB, 3 dB, 10 dB, anything. But I needed to have 0 dB gain, so I stopped it here only. Okay, so in that way you need to think. Okay, so this will be, now this graph will be same as this graph, because just the pole will be at 2 by RC. Okay, all the graph will be same. So how will you think it from initial? Pole at 2 by RC, pole at 2 by RC, h of 0 is 1 by 2. Okay, it will be some negative value, right? 20 log minus 20 log 2, it will be some negative value, and h of infinity is 0, right? It will be, h of infinity is 0, it will be minus 20 dB, minus infinite dB. Okay, drawing the Bode plot. Now we have a DC gain of minus 20 log tan 2. Okay, so this is minus 20 log tan 2. Okay, then at 1 by RC, sorry, 2 by RC, we will have a slope of minus 20 dB, right? Here we will have a slope of minus 20 dB. So now it will decay down and it will go to minus infinity. It will decay down and will go on to minus infinity. So here we have a minus 20 dB per decade. Okay, so that's it. This is, and this is h of omega in dB. Okay, yeah. So now in this circuit, 0 at 1 by RC and pole at 2 by RC. Okay, so what will occur first? First we will have 0. So h of 0 is 1 by 2. It is some negative value minus 20 log 10 2. Okay, and h of infinity is 1. It means 0 dB. You need to come to 0 dB. Okay, this is h of omega in dB. Okay, and this is omega. So you have a gain of, first this is the gain, minus 20 log 10 2. It will go on to some values. Then we will have a 0, because 0 is lesser, right? Then we have a 0, means we will have a positive slope, right? Then a negative slope will come at 2 by RC, so it will go to 0. Why did I stop it here only? Because I knew at infinity I need to make 0 dB gain, so that's why I stopped it here only. So this point is 2 by RC, sorry, 1 by RC, because we had a 0 here, 1 by RC, and this point will be 2 by RC. Here we had plus 20 dB per decade gain, and here we had 0 dB per decade slope. Okay, and the gain is here 0 dB. So I hope you are getting the concept here. Okay, in this one, 0 at 0 and pole at SRCS I have written, SRC only I should have written, and pole at 1 by 2 RC, right? And h of 0 is 0 means minus infinity dB, and h of infinity is 1 by 2, right? H of infinity is 1 by 2, that means some negative value. Okay, so drawing the Bode plot, again we will start it from negative. H of omega in dB, and this is omega, right? From minus infinity, so it is starting from minus infinity, and at some point 1 by 2 RC we will have a 0. So at minus infinity it is starting, and it is going with minus 20 plus 20 dB per decade, because we have a 0 at 0, so it is going with plus 20 dB per decade slope, plus 20 dB per decade slope. Then at 0, so at pole 1 by 2 RC we will have a minus 20 dB slope. So plus 20 and minus 20, it will give you 0 dB slope. So it is 0 dB per decade. Okay, plus 20 and minus 20 will give you 0 dB slope. And why did I stop it here and not here? Because I knew at infinity I need to make negative value, so it will be minus 20 log 10 2. Okay, so from now onwards you should first draw the Bode plot, then you should see the solution. I guess it is the same we had done before, I guess. Yeah, okay, let's see again. The pole is at 2 by RC. First we are writing 0. First we should write 0 is at 1 by RC, and your pole is at 1 by 2 RC. So your pole will come first and 0 will come later on. So h of 0 is 1, it means 0 dB, and h of infinity is 1 by 2, it means minus 20 log 10 2 dB. Okay, now drawing the Bode plots. H of omega in dB to omega. Okay, so first we are having a DC gain of 0 dB, right? So first we are having a DC gain of 0 dB, DC gain of 0 dB. Then at 1 by 2 RC we will be having some pole, right? So at this point 1 by 2 RC we are having a pole. For pole we will have minus 20 dB per decade slope, right? This is your minus 20 dB per decade. Okay, and at 1 by RC we will have a 0. At 1 by RC we will have a 0. So it will go on like this. Okay, so this value is some negative value, so it is this value, minus 20 log 10 2 dB. Okay, so like this is going. I hope you have understood the concept now. Plus 20 and then we are having a 0, so it minus 20 plus 20, so it will be 0 dB per decade. Bode plot is a approximate plot, right? This is not the exact plot. Exact plot will be something like this. In this question it will be something like this, okay, or more precisely it will go like this, but this is approximate plot. Like before first pole we are taking gain to be 1, means we are taking gain to be 0 dB before the pole, but it is not certain. Before the pole we will have some gain, right? It will be not 0 dB. So Bode plot is a approximate plot, not the exact plot. Okay, so in this one, yeah, this same we have already drawn. SRC upon 2 SRC plus 1 we have drawn, I guess. SRC upon 2 SRC plus 1. This is the graph we have already drawn, right? So, although the circuit is different, but the graph will be the same. So, this same graph we will be having. This same analysis and this same graph we will be having. Okay. So, no need to write 0 and 4. So, this is the same graph we will be having. And this also we have done, I guess. SRC plus 1 upon 2 SRC plus 1. SRC plus 1 upon 2 SRC plus 1. So this same graph we will be having. The transfer function is the same, right? We didn't calculate the transfer function by conventional method. Okay. In the previous video only I have taught you the concept, right? This is not the conceptual, this is not the conventional method. We wrote the transfer function intuitively, right? First we found poles and zeros, then we wrote the transfer function. Okay. Now this one, SRC plus 1 upon SRC plus 2. This also we have done, I guess. SRC plus 1 upon SRC plus 2. So yeah, this is the transfer function. This also we have plotted. So this will be the same. Yeah, I will copy that later on. Okay, I will copy that later on here. And the last one is 1 upon SRC plus 2. That also we have done, or you can simply plot it, right? At infinity, at 0 you are having a negative gain, and at infinity you will have a 0, means minus infinity gain. So it will start like this, and then it will start like this, then at a pole it will go to infinity. So this will be the plot. So h of omega in dB versus omega. Initially at 0 you have some negative gain, and then there will be some pole 2 by RC, and it will have a minus 20 dB per decade. Okay. Now we will see one interesting example. We will see it in next video. Okay. Yeah, so now we will see this question where you have to plot the V naught waveform, and then you need to draw the Bode plots for these conditions. So for these condition also you need to draw the output waveform. Okay. So what are the things you can do? First you can find the poles. These will be constant for every condition, right? So what will be the pole? It will be 1 upon pole will be at R1 R2 in parallel, and C1 C2 is also in parallel, so it will be C1 plus C2, right? And you need to tell the 0. So for 0 this has to go infinite, and this will go infinite at, this will go 0 at infinite frequency. So forget about this. Now only you need to consider this one. So it will be at minus 1 by R1 C1, right? This will go to infinity at 1 by R1 minus 1 by R1 C1. That concept I have already taught, right? So now you need to now we will take first condition. First is R1 C1 is greater than R2 C2. What is the V0 voltage at t equals to 0 plus? V0 voltage at t equals to 0 plus is, at t equals to 0 plus, what is the frequency content we are having? Infinite frequency content. So at omega goes to infinity, this will provide zero impedance. So this will be shorted and this will also be shorted. So complete circuit will be shorted. So infinite current would flow. So so the capacitor will change its voltage so the capacitor will change their voltage instantly. Then your V0 will come 5 into C1 upon C1 plus C2. 5 into C1 upon C1 plus C2. V0 at omega equals to infinity. At t equals to 0, we were having infinite frequency. Because of infinite frequency, this will be replaced by C1 and this will be replaced by C2. Then simply the voltage division 5 into C1 upon C1 plus C2. Right? And what is the voltage at infinite frequency? Sorry, at t equals to infinity. This is the time. Okay. This is the time t equals to infinity. So V0 at t equals to infinity, it will be 5 into R2 upon R1 plus R2. Why so? Because the capacitor will be open circuited. So 5 into R2 upon R1 plus R2, and this is V0 at zero frequency, right? Because steady state we have zero frequency. So at steady, so this is the load. Now the condition is R1 C1 is greater than R2 C2. Now here one value is your V0 at t equals to 0 plus is, or your V0 at omega equals to infinity is 5 into 1 plus C2 by C1, right? And your V0 at t equals to infinity, or your V0 at omega equals to 0 is 5 into 1 plus R1 by R2, right? Now it is given that your R1 by R2 is greater than C2 by C1. So this value is greater. So overall this value is lower and this value is higher. So your V0 at t equals to 0 plus is greater than your V0 at t equals to infinity, right? This value is greater, so this value is greater. If the denominator is greater, the overall value will be lower. So V0 at t equals to 0 plus is greater than V0 at t equals to infinity. So now how will the graph look like? So at t equals to 0 we are having more value. So 5, so from 5 C1 upon C1 plus C2, it will go to 5 R2 upon R1 plus R2. Okay. Later on at t equals to infinity we are having the lesser value. So it is going down. So this is the graph. This is the time domain graph. Now we will see the frequency response. So in frequency response we won't care about the magnitude. Okay. Okay, we won't really care about the magnitude, or you can care about the magnitude as well. This is the magnitude that you can see here. So what you will see here is that you have these poles, okay, and this is the 0. This is the pole, this is the 0. Now you will see R1 C1 is greater than R2 C2. Then you will say that I can't comment which is greater, right? Because this will be lesser than R1 and this will be greater than C2 or C1, sorry. This value will be lesser than R1, right? R1 parallel with R2. So this will be lesser than R1 and C1 plus C2 will be greater than C1, right? So one value is less, one value is higher. So how can you comment? So you think that you can't comment, but you can really comment. How? This is the condition, right? R1 C1 is greater than R2 C2. Here you can see that your V0 at omega equals to infinity is greater than your V0 at omega equals to 0, right? At infinite frequency you are having more gain, and at zero frequency you are having lesser gain, right? So if at infinite frequency you are having more gain, and at zero frequency this is some gain, right? 5 R2 upon R1 plus R2. So this is some DC gain. So let us draw the frequency response first. So first you are having this DC gain, some DC gain you are having. This is the DC gain. Now this is at omega equals to 0, right? Now at omega equals to infinity you are having, at omega equals to infinity you are having more gain. So your graph should go up, right? Your graph should go up. So first you need to have a 0 here. right? First you need to have a 0 here, then you need to have a pole, so that the graph should go up, so that the graph can go up, right? This is the gain at omega equals to infinity. This is plus 20 dB per decade, and this is 0 dB per decade. Okay, this value is 20 log 10, this value 20 log 10 into this value 5 R2 upon R1 plus R2. Okay, and this will be this value 20 log 10 5 C1 upon C1 plus C2. Okay, so if we had more gain at infinite frequency, that's why we took the graph up. So first we had this 0. What was 0 at? 0 was at 1 upon R1 C1, and then we had this one 1 upon R1 plus R2, sorry, R1 parallel R2 into C1 plus C2. Then we had this 0. First it goes up, then. So I hope you have understood this concept. So it has to go up. If we had a pole first, if we had the pole first, some DC gain, if we had the pole first, then it would have minus 20 dB per decade. Then we had a 0. So it would go to 0 dB per decade. So it would go down. Then we had omega equals to 0, we had more gain, and omega equals to infinity, we had lesser gain. So that would be the condition. But this is not the case here. Okay. Now for second condition, I guess you have already have understood the concept. R2 C2 is, sorry, R1 C1 is lesser than R2 C2. R1 C1 is lesser than R2 C2. So your output would go, in previous condition your output was going down, right? This output was going down. Now your output will go up. Okay, so now your output will go up. So initially you had gain 5 into C1 upon C1 plus C2. Then eventually you are having 5 R2 upon R1 plus R2. So this was your V naught T, right? With respect to T. And now your Bode plot also you can draw, right? At omega equals to 0, you are having lesser gain. At omega equals to 0, you are having more gain, right? So at omega equals to 0, you are having more gain, right? Then you will have a pole, then you will have a 0. Sorry, first, yeah, first we had here, we had a pole, okay? And here we had a 0. So the position is interchanged now, because this is at omega equals to infinity. At omega equals to infinity, this is your gain, right? So this is lesser. This is 10 log 10 5 C1 upon C1 plus C2, and this is omega equals to infinity, that is more gain. Oh, sorry, omega equals to 0, that is more gain. 5 R2 upon R1 plus R2. This is the gain at t equals to infinity and omega equals to 0. So this is the gain at omega equals to 0. This is the gain at infinity. This is R equivalent, C equivalent. This is 1 by R1 C1. And this is the graph. Okay. Yeah. That's it for the second one. And for the third one. Now in the third one, condition is R1 C1 equals to R2 C2. So your V naught will be, if R1 C1 equals to R2 C2, so your V naught will always be equals to, look, R1 C1 upon R2 C2. So first it was 5 C2 upon, sorry, 5 C1 upon 5 C1 upon C1 plus C2, right? At t equals to 0 plus. At t equals to 0 plus. V naught at t equals to 0 plus. And your V naught at omega equals to infinity. And your V naught at t equals to infinity is 5 into R2 upon R1 plus R2. So V naught at omega equals to 0. So now from here you can see R1 upon R2 is equals to C2 by C1. So both the values are equal. V naught at t equals to 0 plus is equals to V naught as t equals to infinity. So it will always be at a, so the graph will be So this will be the graph, always constant, right? So the value is 5 R2 upon R1 plus R2, or you can write 5 C1 upon C1 plus C2. So the graph will be always constant. Okay. And what will be the Bode plot? A DC value, right? The Bode plot will also be a DC value, H of omega, or V naught by Vs in dB omega. So it will be a DC value. Okay. This will be 20 log tan 5 R2 upon R1 plus R2. So it will be a DC value. Now in this condition, what is the order of circuit? First order, right? This is simply first order circuit, right? This also is first order circuit because it had one pole, right? What will be the order of this circuit in this condition? What will be the order? Zero order circuit. Why so? Because it had no pole, no zero. Zero can't decide the order, only poles decide the order. So no pole. It has no pole. So the order of the circuit will be zero, because just as you are applying the input, your output is stable. Just as you applied the input, your output is stable. So this is zero order circuit. Okay, it had no pole. This is zero order circuit. So you should note it down. Okay, so this was the condition. This was the complete analysis for this question. Okay, yeah. So now we will see the second order circuits. Okay, thank you. Yeah, hello everyone. There is actually a small error here. Like this will be this gain, right? We are plotting the gain here, not the magnitude of output. So this will be this value 20 log 10 R2 upon R1 plus R2, and this will be negative, right? Because this will be lesser than 1, so this value will be negative. So we are writing the gain, not the magnitude. So V naught by V in would be R2 upon R1 plus R2, or C1 upon C1 plus C2, and in 20 log 10. So this is negative, right? So this will be negative here, and that 5 shouldn't be there. Okay, so this was one small error. Hello everyone. So now we will see the Bode plots for second order circuits. We will also see the time domain analysis of second order circuit in the next lectures. Okay. So now first let us draw the Bode plots. So at omega equals to 0, you have omega equals to 0, this will provide infinite impedance, this will provide also infinite impedance. So your V naught will be 0. That means your gain is minus infinite dB. And you have a 0 at 0, 0 at 0, and you have a 2 poles. Pole are 2. We have 2 poles, but you don't know the location of poles, and that's fine, right? Why so? Because we are starting from minus infinity and we have a 0, so we will have a minus 20 dB per decade gain, minus 20 dB per decade slope. So this is the slope, minus 20 dB per decade. We are starting from omega goes to 0 with a 0, so minus 20 dB per decade slope. Then we will have some pole, minus 20 to 0 dB per decade, then minus 20 dB per decade. So sorry, it is not minus 20 dB, it is plus 20 dB, because we have a 0 here. Then we will have some pole here, so plus 20 minus 20, so it is 0 dB per decade, and then more minus 20, so it is minus 20 dB per decade. Okay, and this is omega, and this is h of omega in dB. Okay, so this is the Bode plot. Now in this question, the transfer function you can write, right? So h of 0 at omega equals to 0, this will provide infinite impedance, this will provide also infinite impedance. So your gain will be 1, and you have, it will be 0 dB. And h of infinity, h of infinity, this will provide 0 impedance, this will also provide 0 impedance. So V naught equals to V in. So your gain will be 1, and this will be 0 dB. Now you don't know the location of poles and zeros. Okay, now you don't know. So what you can do, in previous example, it was certain that you are having only 1 0 at 0. Okay, but now you are having 0 at 1 by r, zeros at 0 at 1 by r1 c1 and 1 by r2 c2, and poles are 2. right? So now if you draw the Bode plots, before drawing the Bode plots, you just know that you will start from 0 and come down to 0. Okay, you know that, you know that. So you can go like this, or you can go like this, but there is no other way. Like, let us take all four conditions. Like, let us take first condition. This is the order: pole, pole, 0 and 0. Okay, this is the order. Can this happen? Let us see. First you will first the DC voltage, first the DC 0 dB, then there is one pole, means minus 20 dB per decade, then one more pole, means minus 40 dB per decade, then one zero, it means plus 20 dB per decade, then one more zero, so it would come down to 0 dB per decade. So this will go like pole, here we had pole, again we had pole, then we had a first we had pole, then we had pole, then we had a 0 here, then again we had a 0 here. So this was minus 20 dB per decade, then minus 20 more, so plus 40 dB per decade, minus 40 dB per decade, then minus 40 plus 20, so again it is minus 20 dB per decade, then minus 20 plus 20, so it is 0 dB per decade. So equal number of poles and 0, so eventually it will go to 0 dB per decade, but here you had 0 dB and here you had some value, some negative value, right? So this is not correct. You should start from 0 and end up with 0 dB only, 0 to 0. So this is not correct. And in the same way, this 0 0 and pole technique will not work. Okay, in the same way it will not work. It will just the opposite of this one, just the mirror image of this one. So this will also not work. So what are the two conditions that can work? So pole 0, pole 0. In this condition, what will happen is that these are the two conditions that can work. Okay, so this is h of omega in dB and this is omega. So first you had 0 dB here, then there was some pole, so minus 20 dB per decade, then you have a 0, so from minus 20 plus 20 it will be 0 dB per decade, then you had a pole, from 0 to you will go to, first you have a pole minus 20, then plus 20, then you again have a pole, so minus 20 is 0, then again you will go to minus 20, then again you will come to 0. So this condition will also not work. Do you understand it? Here you had pole, then you had 0, then you had pole, then you had 0. In this condition what is happening is that pole minus 20 dB per decade, then 0 dB, then again minus 20 and then 0. Again this graph is taking place. So this is also not possible. And the fourth condition, that 0 pole, 0 pole, 0 pole, this will also not work. Okay, this condition will also not work. So now we need to, now we have understood that what condition can work. So this is the fifth condition, that this can work: pole, 2 zeros and then a pole, this condition can work. And sixth one is 0, 2 poles continuously and then a 0. Okay, you don't know if R1 C1 is greater than R2 C2, these all things you don't know, and also you don't know the location of poles, but you know what will be the nature of graph. The nature of graph can be in two way. Okay, I'm talking about the first some DC gain, then you have a pole, so minus 20 dB per decade. So minus 20 dB per decade. Okay, then you have a 0, so minus 20 to 0, minus 20 plus 20, so it is 0. Then you have one more 0, so one more 0 will provide 20 dB per decade. Okay, then you have a pole. So from 0 to we are coming to 0, so this is 0 dB, this is minus 20 dB per decade, this is 0 dB per decade, this is plus 20 dB per decade, and this is 0 dB per decade. This is omega, this is h of omega in dB. Okay, so here first we had pole, then we had a 0, then we had a 0. Okay, so it can go in this manner. Okay, one thing I can sense here is that, like, this graph is the only possible way. Like, you have understood, if we draw the graph here, this will go like this, right? This will go like this, right? You must have understood it. 0, pole, pole, and then a 0. You must have understood it. So if you draw this graph, what you can conclude here is that your gain goes higher than 1. Higher than 1. Here your gain goes higher than 1. Right? Here your gain goes higher than 1. But here the gain is always lesser than 1. Gain is always lesser than 1. That means your V0 is always lesser than V in. It can be equal to V in sometimes, but it will never go above, right? So this is the only possible graph, because when you see the time analysis of this one, if you see the time analysis of this one, your V0 will come like this. This go down and this go up. So your V0 never goes above V in. And also you can sense here is that this V in is charging both of the capacitors. So how it will go above V in? So it can never go above V in. Right? So you have understood that this V in is charging both of the capacitors, so it can never go above V in. So your gain will never be greater than 1. So if your gain is never greater than 1, this is not possible, this is not possible, this is also, this is the only graph possible. So this will also be not possible. Okay. So this is the correct one. So there is only one probability, and this is the correct one. Okay, because the gain will never go above 1, so the gain has to be negative, so it has to go like this only. Okay, so this is not, this is also not the possibility, this is the only possibility. Okay, this is correct. Now for the second one, now this is easy, because you have no 0 here, right? You have no 0 here. So here your h of 0 is, at omega equals to 0, you have infinite impedance, so your V0 equals to V in, that means 1, that means 0 dB gain. Okay, and your h of infinity is 0, that means minus infinity dB. Omega goes to 0, infinite impedance, V0 equals to V in, 1 gain, so 0 dB gain. And omega goes to infinity, this will provide 0 impedance, this will provide 0 impedance, so your V0 will be 0, so you have minus infinity gain. So it will start from 0 dB, it will start from 0 dB, then it will have some pole, okay, then it will have one more pole. And it will go down to minus infinity. Okay, here you will have one pole, and here also you will have one pole, and this is omega, and this is h of omega in dB. Okay, yeah, so there is no confusion in this one, simply this gain. Okay, you see the gain 0 dB and then minus infinity dB, only two poles, no 0, so simply minus 20 dB per decade here. Okay, and then here minus 40 dB per decade. Okay, so that's how the graph goes. And now about this one. So again you will see omega equals to 0, omega equals to 0. This will provide infinite impedance, this will provide infinite impedance. So gain is 1. So that means 0 dB. And at omega equals to infinity, this will provide 0. So V0 will be 0. So it will be minus infinity dB. So it should start from 0 and should go to minus infinity. Okay. So in this one also we need to think. Okay. So we will again take the conditions. So here we have 1, 0 and 2 poles. Okay. And one thing also we know is that your V0 will always be less than V in. Since your V0 is always less than V in, that means your H of omega in dB will also be less than or equals to 0 dB. Okay, at 0 frequency it is equals to 0 dB. So we will take the conditions like first condition we can take 0, pole and pole. Okay, so that's the condition we are taking, 0, pole and pole. So we will start from 0 dB. We'll start from 0 dB. Then we have a 0. Since we have a 0 first, it is going above 1. So let us draw the complete graph. Then we have a pole. Then again we have a pole. Okay. So it is going above 0 dB. Here for some frequency h of omega is greater than 0. Right? So it is not possible. Not possible. Okay. Now take pole 0, pole. So first 0 dB, then you have a pole, then you have a 0, then again you have a pole. Okay. First you had a pole, right? Minus 20. Then you had a 0, 0, 0 dB. Okay. Then you had a pole, then again minus 20. So it is always less than, I guess this is possible, right? So h of omega is less than equal to 0. And first you had a pole, then you had a 0, then you had a pole. So this is possible. And let us see if other conditions are possible or not. Let's see. So we are taking 0 pole pole. We can take, look, 0 pole pole we have taken, pole 0 pole we have taken. Now more condition we can take is pole 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 0. That condition we can take, right? First DC, then minus 20, then minus 40, then again minus 20, right? This is pole pole over 0, minus 20 dB per decade, minus 40 dB per decade, then plus 20 dB, sorry, minus 20 dB per decade because of 0. So this is also possible, right? Because it is, this is h of omega. So this is also possible, right? So there are three conditions. There are pole pole 0 and two equal conditions. So I guess how many possibilities are there? So I have wrote down all the possible condition. I guess these are the only possible condition. Pole pole 0, pole 0 pole, 0 pole pole. So we have done the analysis of all three. So this was also possible and this is also possible, right? Both are possible, right? Because at omega goes to infinity we are having this value. So this is also fine and this is also fine, right? So yeah, so in this condition these two are the condition, and in previous one also I have written all the possibilities here. Pole pole 0 0 0 0 pole pole 0 pole 0 pole pole 0 pole 0 pole 0 0 pole 0 pole pole 0. So we have done the analysis of all, but this was the only correct one. Okay, because the graph shouldn't go above 0. So this was the only correct one. So pole 0 0 pole 0 0 pole. This was the correct one. Okay, so I hope now you have understood the concept. So intuitively you can also draw the response of second order circuit, frequency response of second order circuit. They can draw the Bode plot or draw the frequency response. So that's how you can draw the frequency response. And now I hope you have understood the complete concept of Bode plots. Now we will see the time domain analysis of second order circuit. Okay, thank you.